Today's lecture is going to be more introductory. I will try to describe you what we are going to do. I will try to give you some basic concepts and understanding of the goal of this subject. We will discuss about grading system, but you're familiar to my requirements. Nothing is new here. And some organizational things. So let's start. As usual, I'm Denis Alexeyev, still PhD in finance and candidate in economics. So you know this thing, how the course is connected to the other courses. So we have built the probability framework. We are now working on the connection of the probability models with the real data, which is also more or less kind of theoretical, but I'm trying my best to show you the practical applications of this. So now we are here, Econometrics, and so here we will do more practical things using all the tools developed in those two previous courses. And hopefully that if everything is gonna be as planned, next year we will move to the more advanced questions of econometrics, which is called Econometrics 2. But there are the recordings of Econometrics 2 from this year, and they are not publicly available yet, but I hope that after some time I will also publish them. So if you're interested in this second part of econometrics and if you would like to watch in advance, so in some time you probably will find them as well. Well, regarding the grades, as usual, option 1, you do home assignments during the course. We have 9 lectures and 9 exercise sessions, which means that approximately you can count on 9 home assignments. Maybe more, maybe less. I will adjust to your, let's say, pace, but in principle you can count on something like 9 home assignments after each exercise session. Maybe there are gonna be some occasional quizzes on Python together with mathematical statistics, because, well, we are gonna use Python here as well. Well, option number 2, you're familiar to this: midterm plus final, 40% from midterm, 60% from final. Everything is the same. Well, we have a course page. Here is the link. You are already enrolled to this course. Basically, what you can see here is not available to you because those are leftovers from the previous year, and I will be updating all these things because last year students had a very interesting experience. They had econometrics before mathematical statistics, and then I needed to explain them a lot of statistics and probability before. You see that we had this review of probability and statistics, and then we started the essential parts of econometrics. Now you are in more favorable position because you already have all the knowledge and skills from probability and statistics, and now we can start immediately to apply them to the econometric things. So therefore, the page is going to be updated. What you can find here, 3 books that I'm going to use through this course. So the books are available here as well. In the whole course, I will mostly follow the first book, and I strongly recommend you, if you miss something from the lectures, to go there and look at this book. This is, to my view, this is the excellent book for those who start studying econometrics. This next one is also for the bachelors. It's introductory, but somewhat to my vision, well, it's a little bit maybe more complicated, but still still it's a nice book, and I'm gonna use some material from this as well. So this is, let's say, some personal preference. If you want, I was teaching econometrics using this book, then I switched to this book, and it turned out that Stock and Watson works a little bit better. And this book is advanced course in econometrics. I will not ask you to read this book, but if needed, I will also take some material from the book of Hansen. Well, basically, this is a book for the doctoral level, not for bachelors, with more advanced theory of econometrics. But sometimes, why not to go a little bit deeper? So all three books are available here. As for mathematical statistics, I created the links in advance for our course meetings, so let me comment on this. Well, basically we have 10 weeks in advance where we have lectures and exercise sessions occurring in turns bi-weekly. So today is 18th of February. We start with the first lecture. Here is the course ID, and it will repeat every 2 weeks. So here, 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 and here for next 10 weeks. For the exercise sessions, there is another link, and it will also be repeating bi-weekly. Then here we finish our course of statistics, because as you know, we've been doing 2 lectures of statistics these 4 weeks. And then the last 4 weeks of this semester, we will do only econometrics, which means that on Thursdays, here, 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 and here, on Thursdays, we will have lectures, and the course ID, the meeting ID, changes. And on Fridays, we will have exercise sessions. So that's why I decided just to put all the dates and all the meeting IDs here. So for you just not to be confused, as usual, you can, in advance, you can enter the page, click either this link or take the meeting ID and immediately enter the meeting without my reminder on the on WhatsApp chat. So I hope this is useful and this is clear. Well, yeah, here is the schedule from this week till the pre-last week of April. We have 1 class per week, lecture, exercise session, and so on bi-weekly. Then we have 2 classes per week, on Thursdays lectures, on Fridays exercise sessions. So the meeting IDs describe this. Any questions about the organizational things? I guess everything.
Yes. Practical classes, like, they will be with you, yes?
Yes, I will be doing as well the exercise sessions.
So classes will take place of mathematical statistics, or how will it be?
No, wait. So mathematical statistics is a separate course, so everything is gonna be there. For econometrics, we will have the exercise sessions with me, so it means that they're gonna take place online, and at the same time, so next Friday, basically, at this time, we will have the exercise session with me.
Oh, okay.
Mathematical statistics still take place on Wednesday. Nothing changes there.
Thursday, no?
Wait, exercise sessions for mathematical statistics are on Wednesdays.
Oh, yes.
Yes, lectures. So, I mean, this does not interfere our classes for mathematical statistics till 24th. So everything that we have for mathematical statistics is the same. Nothing changes there. So till 24th, we work in the same regime. Only on Fridays now, instead of my lecture of mathematical statistics, we have lectures of econometrics 1 week, exercise sessions the other week. then again lectures, exercise sessions, and then it happens till 24th of April. Then Thursdays and Fridays will be fully devoted to the econometrics. And somewhere in the middle of April, your exercise sessions for mathematical statistics finish. But check, I'm not sure when exactly, on what date, so check this with Klim. What happens there. So yeah, please don't be confused. Everything regarding the mathematical statistics on Thursdays, Wednesdays is the same. Anything else?
No, thanks. Everything's clear.
Good. So let's start to understand what we are gonna do here. So in statistics, up to this moment, we introduced the techniques of inference to make some conclusions about the unknown parameter of probabilities of probability distributions. So that's what we have been doing last 4 weeks. And as I said, yesterday we came to the, let's say, last conceptual thing that we need to understand, hypothesis testing, and then we will start applying them in different circumstances, to different cases. Well, Econometrics does the following. So this is a citation from Woolrich. So Econometrics develops the statistical methods in the way of estimating the relationships between variables, testing the economic theories, or evaluating government and business policies. As you can see, the goals of econometrics are practical goals, right? So we want to find if there is some relationship between two variables which haven't been introduced yet in statistics. We want to test the economic theories. So suppose that there is some scientist and this scientist claims that, well, let's be more precise. So we know from microeconomics, the theory of demand and supply. We know that when price increases, the quantity must be decreasing, right? So this is the theory. This theory has some reasoning, and now econometrics can help us to test whether this theory is applied in real life. Or evaluating government and business policies. Suppose that government wants to, I don't know, support a particular industry. And we want to know whether this policy has a positive effect that is expected by the government or by business. Well, we want to, let's say, make some new marketing policy for the company. We want to attract new clients, whether this policy is efficient or not. Does it have any effect on the subsequent sales? All of these things basically are the questions that econometrics is capable to answer. So for example, I just created several examples. Of course, those are not the only examples, but they are reasonable in terms of economic theories. So does the obtaining of a master degree make your salary higher? Does it make sense to go to the and obtain master diploma, or probably you can get the same result having only bachelor? Well, in principle, we can argue pro or contra about this, but we are not sure about what is the exact effect of this master degree. Maybe there are some other effects that can influence your future salary. Or does the government support making agricultural firms more productive? Whether this support makes sense or not. How to evaluate this? Or does the investment strategy that you probably take on the financial market make consistently positive profits? Which means that your investment strategy and your profits are not random, right? So you are just lucky that you have positive profits, but the profits are the result of exactly this strategy and not the result of just some positive consequences. So those are the questions that must be answered with the help of econometrics. So what is this? What this field does? There is the first holder of a Nobel Memorial Prize in Economic Sciences, Ragnar Frisch, who is the founder of the first journal about econometrics, which is called Econometrica. And so he said that econometrics is unified study of three fields. So economic models from one side, right? So some theories, so mathematical statistics, and that's why we needed all these tools of mathematical statistics, and economic data. So something that comes from the practice. So we want to combine these three things. And in this case, in this sense, well, econometrics might seem to be a bit difficult because most of the times I will be asking you not about mathematical derivations and about something to calculate, but about the meaning of these results. What does this mean from the economic point of view? How, as an economist, you can explain this relationship, or what would you expect as an economist from this question, and something like this. So sometimes for students, it's even harder to think in this conceptual level, on this conceptual level, instead of just making some mathematics in statistics or a probability. So therefore, please be ready in advance that we will start thinking not only from the mathematical side of our life, but also from the practical application. And you must be careful when you make some conclusions. Well, the economic theory concerns the development of tools and methods and the study of properties of econometric methods. Econometric theory, sorry. So there are two different fields of econometrics. So theory develops some tools, how we can answer the economic questions, how we can test theories, how we can test those policies, and so on. And there is another field, which is applied econometrics. And this applied econometrics takes those tools and apply them to build some quantitative economic models, right? So we will mostly do this part, applied econometrics. We will first study some standard and basic methods of econometric theory, and then we will try to apply them immediately to the real life. So how we can make some models, quantitative economic models. So we use these methods extensively. You can find some books, and there is basically a wide field of what is called financial econometrics. And in finance, in risk management, in trading, in investment strategies, econometrics models are used a lot. But, well, I probably will disappoint you, because in this course we will not even try to talk about financial econometrics, because this is too advanced question. And so we will start talking about some elements of financial econometrics only in the second course of econometrics, because, well, we really need to understand all the basic details. Well, labor economics, something like I asked you about, whether obtaining a master's degree helps you to increase your salary. Macroeconomics, and that's about evaluation of the government policy. Microeconomics, there is microeconometrics, the whole field of microeconometrics and answering the questions that we theoretically discussed in the microeconomics course, marketing, and many other branches of economics, and not only economics, in sociology, some other fields, we use those methods. Well, we need to understand the following. What we do in econometrics is mostly a quantitative analysis. So it means that we are working with numbers, and we want to get some numeric outcome. Because usually in the economic theory, we get an idea of the relationship, of the direction between the variables, right? So, for example, we know that consumption decreases when price goes up. Of course, we did also in microeconomics all the formulas, the derivations, and all those things. But after all, we have the model that says that consumption decreases when the price goes up. But what is the actual quantitative effect? It's not clear. When price of a gasoline, let's say, increases by 1%, so how much exactly consumption goes down? How much percent? We don't know from theory. We just know that, well, there is inelastic demand and probably it will decrease less than by 1%, but we are not sure. And econometrics helps us to estimate, so the term from statistics, to estimate this effect. Still, this effect, the true effect, is not known. And here I introduce these concepts of mathematical statistics. The true effect is not known, but based on data, we can estimate this effect and we can say, well, if everything has been done correctly, then our best guess for this effect is this number, like 0.5%, something like that. Well, as I said, because we use the data to answer these quantitative questions, our answers always have some uncertainty. We cannot be 100% sure about that this exact number is a true number. And that's where statistics must help you to understand this concept. So a different set of data would produce a different numerical answer. See the similarities with mathematical statistics, I hope. And the conceptual framework is built fully on the mathematical statistics. We want to provide a numerical answer to the question, the estimate in statistical terms, and the measure how precise the answer is. Because the estimator has sampling distribution, right? The estimator has variance. And we want to also know something about this variance, how this measure is precise. So what you see on this slide exactly repeats what we have discussed in mathematical statistics. And, well, we are gonna ask the same questions here. What is my best guess? And what is the possible deviation of this best guess when the random sample is changed? Maybe there are any questions here. I hope that you see the parallels with statistics here.
Yes, it is understandable.
So, but the most important difference from statistics is here. We want to find what is called causal effects. What is the causal effect? So the question we ask in econometrics concerns the causal relationship. So change in X leads to the change in Y. That means, and this is what you really need to understand and keep in mind through the whole course that we are gonna do. We really want to understand the causality. So causality means that a specific action, for example, obtaining a master's degree, leads to a specific measurable consequence. For example, having a higher salary. So what we want to find is exactly the effect of some action. And this is called causality. Well, here is a question to you. If you want to answer this question, what is the best way to measure this causal effect of a master's degree on salary? Can you come up with some idea? If you want to answer,
Analyzing data.
how exactly? What data do we need?
Like we need to collect a certain sample of people who obtained a master degree.
Okay, we have a sample of people who obtained a master's degree. Then what?
Then look at the previous salary and the higher salary, or if we want to check it, like we need a sample of people with a bachelor and a sample of people with a master degree and compare them.
Okay, so let me briefly write down your idea. Oops. So we need a sample of people with, as you said, bachelor degree and master degree. Okay, nice idea. What else we need to see in this sample? So suppose we have this sample. How can we answer the question how master degree affects the salary?
And we need to know the income.
Okay, we need to collect their salary. We need to collect the data on their salary. Okay, nice. Then what? Suppose we collected.
Like to compare them if it is higher in average or less.
Okay, so compare the average. Compare the average salary of people with master degree and people with bachelor degree. Okay, nice idea. That's actually what comes to your mind first. Does anybody see any problem with this approach?
Maybe we need not only bachelors, but other.
Okay, maybe we need somebody else. I don't know, like doctoral level degree or no degree.
I mean, should we compare master and everything that is less? Or how?
Well, basically you cannot get master without bachelor, right? And if you want to answer what is the effect of master, probably we want to, so probably the first idea was correct. We want to compare master with bachelor because the bachelor is the previous level and you cannot jump to the master without having bachelor. But, well, we can take doctoral degree, we can take no degree, just, to compare as well. Still, is there any problem with this approach?
There will be uncertainty.
About what?
Like we won't be able to collect all the data, all the population.
Well, sure, we will take the random sample. I totally agree that we need to take a random sample. The sample must be random. So suppose that you call a phone and ask a person whether the person has a master's degree or not, or whether the person has a bachelor degree or not, and then ask about salary, right? So you will be able to collect a random sample. Still, okay. Suppose we have the following result, just without collecting any data or whatever. Suppose we have the following result. So the average, so let me use the the notation from statistics. So the average salary for, or sample mean salary for bachelors equals, well, I don't know, let's say 1000 USD, and the sample average for masters is equal to 1300 USD. Okay. Can we say that this difference is happened due to the difference in education?
I guess no.
Why?
There are more details of the situation. Something that is we can't see, or we
What
don't
do
have
you
data
mean? What you can see in this result?
in this result, we can see that the average salary of master's degree people is high.
Well, we see that the average is higher, and basically maybe next year or 2 years, next week, sorry, or maybe 2 weeks after, we will discuss how statistically to verify that the true population mean of salary for masters is higher than the true population mean of the salary of bachelors. So we will know how to do this statistically and how to prove that the population mean is really higher. The question is, can we claim that this difference occurred because these people have master degree and these people have bachelor degree? Can we establish this causality that, well, the person goes obtain the master degree and the master degree only helps to this person to get the higher salary?
I guess if you ask this question, then no, we can't say so.
But what I want to hear from you is the reason why we cannot say about this. Maybe somebody else has ideas. What prevents us from claiming that only master degree has this positive effect?
The positive effect is the higher salary, yes?
Yes, the positive effect is a higher salary. What may prevent us from claiming that this positive effect occurs because of the master degree only?
Because there are people without master degree but with higher salary, something like that.
Okay, it might be that there are people with bachelor degree and the higher salary, but we are estimating this effect on average. On average, we have that this is higher.
So
we just can't assume that this is only because of master's degree, just because we don't know other details.
Which exactly details you want to know?
I don't know any. It can be anything. For example, if let me say so that master degree requires some time and money, and only people with just, for example, with just with this in this situation to obtain the master's degree can like they are already in a winning position.
Okay,
People
so
who
there is some initial difference between people who are with bachelor degree and with master degree. And those underlying differences may affect both their degree and their later salary. And probably, you're right, probably those people who are more educated, more motivated, more skillful, they go and get their master degree, and those skills help them to earn the higher salary in the future, right? So that's why this difference may occur not because of the master degree, but this difference may occur because of some underlying and not observable in this question features of those people.
Exactly.
You're right. What we must do to avoid this problem, what people in science do to get the exact knowledge about this causal effect. Well, as we said, we can write here that, well, it is possible that people who decide to obtain a master degree are more motivated, skilled, smart, and because of these features, they are able to get a higher salary. That's true. So what we should do if you want to understand the causal effect? What people in science do when they want to understand the effect of vaccine, for example? When some pharmaceutical company want to claim, well, there is 99% efficiency of our vaccine against COVID. What do they do in order to claim this? And they are really able to claim that exactly their vaccine has this causal effect. Not the immunity system of a person, not something else, but exactly this. What do they do?
I guess
Only one word. What do they do? How do you call their action?
testing.
Not testing. No.
Calculating.
Come on. Before calculating and all these things, so what do they do in order to verify that exactly vaccine has this causal effect?
They infect people.
No, they don't infect people. Of course, they test their vaccine on people. But how do they do this? They ask you whether you want to get a vaccine or not, or they do something differently. Okay.
Placebo.
Okay,
So
but
they create
how do
focus
they
groups?
decide who gets placebo and who gets this drug?
It's just random.
It's random. Yes, they make an experiment. They randomly select who gets the treatment and who doesn't get, and who gets this placebo. Right? So everything is decided at random. What should we do? In this case, if you want to verify that exactly master's degree has an effect on your future salary. So how to establish the causal effect? How should we do this? By analogy with the medical testing.
Maybe just to say the работодатель that you have
No. Come on. No. Not to employer. No.
They should find identical twins and test them.
No, not identical twins. But okay, so it's a nice idea about identical twins, but nobody tests drugs on identical twins. No. So you have some people who are the volunteers, right? So we can first collect the volunteers. But then the next step, what exactly should we do with these volunteers in order to have the same thing as with the drug testing?
Give them drug.
What is the drug here?
Master degree.
Education.
Master degree. So how should we decide about the master degree?
Or it's random. Like
Randomly,
select them.
yes, we should randomly. And this is the most important thing. We should randomly send some people to the master programs, and some people should be left with only bachelors degree. And then in the third step, we should measure their average, measure and compare their average salaries. And because we randomly decided who gets the master degree and who does not get the master degree, it is independent to their abilities, right? So here in the first problem, in the first approach, the decision whether to go and get master degree or not is influenced by a person. This is the choice of a person. And of course, more skillful, more smart, more capable person decides to go and get master degree. And this gives him or her the higher salary in the future. In this case, we make this choice by ourselves with the help of some randomizer. We can just run some random number generator and do this and decide, so you and you. It doesn't depend on whether this person is smart or not smart, motivated or not. We just randomly select them and say, well, you go and get master degree and you don't. And then after some time, when these people are graduated, we collect their salaries, calculate the average salary, and then we see whether there is a difference in their salaries or not. And in this case, we can attribute this difference to the causal effect of a master degree. Now the question is, if it's possible to do in real life.
Not, it will be too long, I
Kind of.
guess.
So how can we ask people at random to go and get master degree? Well, it's not possible, right?
Yes.
It's not possible to decide for a person at random that you go and you don't go. We cannot make an experiments which are, well, which can influence the whole future of a person.
But
well,
try real hard.
That's here.
Convince them.
Well, you may convince sometimes when the pharmaceutical companies are making this testing of drug, they of course ask for the volunteers, and these volunteers are paid, and they probably sign some paper that in case of some negative effects, they don't complain about this. But, well, in economics, I gave you only one particular example, which is probably easier to understand. But whether if we, for example, decide on some other things, it's quite problematic to make these experiments because they can really influence the whole life of this person. They are just unethical. So that's why, yes, here on the slide, ideally we want to do the following. We make some people study on master degree, some people live with bachelor degree. We decide this at random, and then, well, the randomization ensures that any other differences between these people, abilities, IQ, background, motivation, are unrelated to the studies. They simply, in probability terms, they are independent And after some time, we measure the salaries of the participants, and the difference between the average salary exactly shows the causal effect, numerical causal effect of a master degree. As we discussed, well, this is called a randomized control experiment, and this, why controlled? Because we have a control group which gets no treatment, no master degree, and a treatment group which gets this treatment, a master degree. So this is the terminology from this from the sciences that we can make these experiments, something like biology, physics, pharmacy, and so on. So randomized because we randomize the treatment between these people. So what is the most important here? The random assignment eliminates this possibility of systematic relationship between how smart is the person and whether she or he receives a master degree. And if we have, so now we introduce the idea of asymptotics and law of large numbers. If we implement this on a large scale, so our sample is large enough to claim that our results are valid, so then we will yield an estimate of this causal effect of the outcome, right? So we compare the differences in average, and this difference is gonna be exactly the numerical estimate of this effect. Yeah, as we discussed, it's not possible to do in practice. In many applications, experiments are not possible because they're unethical, first, impossible to execute satisfactory, second, and maybe sometimes it's too time consuming because, well, if you want to make this experiment, it will take you a lot of time, right? You need to make this experiment over people for, well, maybe 10 years, maybe even longer, and, well, might be expensive, right? So you need to, as Vlad said, you need somehow to pursue these people to take part in this experiment. So probably you need to pay them for the participation in this experiment. And, well, if the person understands that he or she will live because of the randomization without a master degree, and probably the whole future life is going to be ruined, this person would ask you to get high enough benefit for this. Well, but why are we talking about this? So please be careful. So now I demonstrated you how people initially start to think about this causal effect. They think that if we collect a sample of people with bachelor's degree and master degree, and if we compare the difference in their salaries, then we have this causal effect. It is not correct. We should be careful about all these not included effects that can affect both your choice for the master degree in this case and your outcome in the salary. And I hope that you will retain this all the time. This is basically, it's not econometrics, it's logic. So usually, so now people do not have the logic in the school, but still you need to keep this logic as much as possible with you, formal logic, that this difference cannot be attributed to the difference in the master and bachelor degree only. We may have many other effects that are not observable here. Well, we can claim that among these two groups there is a difference, but what is the reason for this difference? We don't know. Only until we make this experiment. And this is the problem. This is the problem of econometrics. We want to establish these causal effects in economics, that something makes an effect on the other variable But usually we are not able to run these experiments, and we are in trouble with this. Usually we have, instead of experimental data that we can gather with the help of experiment, which is too expensive, difficult to administer, unethical, and relatively rare. So there is an experimental economics field, and well, people try to make these experiments, but those experiments are mostly like games. Sometimes they reveal some interesting results, but they are not able to answer these difficult questions. And let me just give you another example. So if you want to understand how, let's say, the change in the interest rate of a central bank would affect the productivity of the economy, and if you want to answer this question with the help of experiment, what does this mean? The countries must randomly select their interest rates. Well, it will probably ruin the whole economy if we will allow for such kind of experiments. So that's why in in the majority of econometric problems, we do not have this experimental data, only in some narrow field. Usually we have what is called observational data, what Vlad proposed. Just go and ask people whether they have bachelor or master degree and what is their salary. Well, and this observational data definitely has some problems. It makes, first of all, it difficult to estimate the causal effects. In the real world, this treatment, master degree, is not assigned at random. And it is difficult for us to sort out the effect of this treatment from the other relevant factors. We simply cannot claim that exactly master degree provides this result that we observe in the data. And econometrics, as the specific study, exactly develops the methods to solve these problems that we encounter in the real world. If we want to estimate causal effects, but we have an observational data, how we can overcome this limitation of this observational data, that the data is generated not at random. How we can still claim that there is a causal effect of, let's say, master degree on a bachelor degree. So I hope that I made you interested in this field and in the future study. So how we can, what we are gonna do. Of course, don't be very kind of optimistic that we will not answer this question right away from the first lecture, but we will go in this direction. And well, the most advanced methods for establishing these causal effects are left for the second part of econometrics, just because they are too advanced to start with them. But you always must to keep this in mind. Our ultimate goal is to establish the causal effect. This is very difficult to do, and we need to properly make all our steps before claiming that, well, we have established something which looks like a causal effect. Any questions here?
No.
No.
So that's how our field, economics, is different from other sciences. So biologists, physicists, chemistrists, they are able to make experiments because their experiments usually involve something, not live being, right? Not people. While in economics, everything is related to people, and as I said, it's quite problematic to make experiments on people, on firms, on government, on countries, and so on. So now, as we started to discuss about the data, there are different types of econometric data, and those different types have their special names, and we need to know these names. So the first type of econometric data is called cross-sectional data. So this is the data on different entities, workers, consumers, firms, governmental units, countries, whatever, for a single time period. So what we have discussed before is more or less exactly the example of cross-sectional data. You take, let's say, well, in this case, if we want to collect this data, we will do something like this. So our sample is gonna look, for example, like the person 1, 2, 3, 4, right, and so on. So person ID. Usually we don't want to reveal the names of these people or something. So here degree, and that's gonna be master, bachelor, master, something like this, and salary, right? Something like, I don't know, 900, 700, 200, 500, and so on. So that's gonna be the table. So we collect this data at one moment of time, and this is exactly the example of cross-sectional data for a single time period. There is another type of econometric data which is called time series data. For time series, we have a data for a single entity, person, firm, country, stock, collected at multiple time periods. So the example of this time series data you have seen in one of the tutorials where we analyzed the stock prices of different companies. You have different time periods, and you have the observation of one entity, price of a particular stock. So this is the example of time series data. If we merge these two types of data, we will get something which is called panel data or longitudinal data. So this is the data for multiple entities in which each entity is observed at 2 or more time periods. So the whole table on the stocks, like one stock, second, third, fourth, and so on, and the time periods is a particular example of this panel data. But usually we may get the information about different time periods and about different variables for the same observation. In this course, in the first part of econometrics, we will mostly discuss the cross-sectional data, and we will build all our methods only for the cross-sectional data. In the second econometrics, we will discuss the panel data, and the half of that course is going to be devoted for time series and the special methods how to work with those time series, because the time series stands separately, and as I said, this is the fundamental thing to build the financial econometrics, because, well, everything in finance develops in time: stock prices, interest rates, currency exchange rates, and so on. So therefore we need to understand how properly to model these objects. Yes, as I said, these two types of data are discussed in econometrics too. So here are just some examples taken from the book. Cross-sectional data. So the table shows us, and we are basically gonna use this data a lot. So this is the data on the test scores and some other variables for California school districts in 1999. So we have a school district from 1 to 420. We have the average test score on the 5th grade. So there is some exam. So we will discuss about the empirical situation in the next lecture. We will start working with this data. So there is an average test score. There is a student to teacher ratio. So how many students per one teacher are in this district. expenditures per one student in dollars, and the percentage of students learning English, so which means that the percentage of those students who are non-native English speakers. So you see that everything is collected for one time period, for a single time period, and we have different variables that are collected for every observation, which is district in this case. Well, time series are here. For example, we have the quarterly data from 1960 quarter 1 to 2017 quarter 4 for two different series. One series is GDP growth rate for the United States in percent, and another is the term spread in percentage points. So term spread is the difference between interest rates on the long-term and short-term bonds. So you see that this is similar to what we had for the stock prices. And finally, the panel data, which is the data on different entities, in this case, the states, and different years for different variables. Well, look, we have the state, for example, Alabama 85, and here we have Alabama 86, Alabama 87, and then for every entity and every time period, we have the observations of cigarette sales, average price, and taxes on these salaries. So we will, as I said, if everything is going to be successful and the plans are going to be the same, so the next year we will discuss about this data, so how taxes affect the cigarette consumption.
What do you mean by the plans? Like, if we do good?
No. I mean, so nobody knows. Maybe there is going to be some changes in your curricula, maybe, well, because the curricula changes all the time. So who knows? Maybe the administration of the university will decide not to put the Econometrics 2 in your study plan next year, whatever. Well, you never know.
Okay.
Or maybe somebody else will teach Econometrics 2. So you know that everything there is uncertainty, right? So we live in the world of uncertainty. We cannot be 100% sure. So that's why, I mean, kind of, if everything goes as planned, then next year we will discuss about this. If something would change, well, probably you will be discussing not with me, or you will not be discussing this. I don't know. Okay, so these are three different types of data. And it seems like I told you almost everything for the introduction. So now, just to conclude, so keep in mind through this course, here our ultimate goal is to quantify the causal effect of one variable or several variables on the outcome. So we want to know what causes some result. This is problematic because usually, as the practice asks, we need to conduct randomized control experiments. It is usually not possible, and we work with the observational data. The observational data fails to provide us with the necessary evidence that there is a causal effect. We can establish that there is some correspondence between variables, right? So if one variable increases, the other also increases, but we cannot claim that this is the causal effect. And during this course, we will try to develop special tools how to solve this problem. Now, there is a home assignment for you. In the book, Stock and Watson, let me show you. You will find on page 54 the review of concepts 1.1 and 1.2. Second. Okay. Page 54. So here, those are two questions. How would you establish the causal relationship between two variables, one and second? So please upload your answers by the next Friday, by the beginning of our exercise session on a Moodle page. And we will discuss with you your answers, what is the proper way to establish this causal relationship. So basically, I want from you to verify that you understood the idea about this randomized control experiment. So how to upload? I will create on the course page here, I will create the link, and using this link, you can upload your answers. So please don't make a plagiarism, think with your own head, and write your own ideas. How would you answer to these questions? Seems like that's all for today. Any questions?
I have a question. Yes. What will we do on our practical classes?
Next class, we will start with the discussion of this, and then we will do some exercises in Python with the database that we are gonna use almost every lecture on this course, the database that I demonstrated you here. The database on the test scores and the student-teacher ratio, because, well, the authors, Stock and Watson, they use this database to illustrate some concepts of the econometrics. And, well, I will stick to this idea, to this database. So just to understand what's there, we will do some calculations. There is no need to introduce some new concepts or some new tools in Python, so you're familiar how to calculate the mean and standard deviation for a particular variable, so you know how to extract a particular variable from the table and how to calculate all the things. So we basically will just make some exercises on this. So yes, please have your Python ready for the next exercise session next Friday.
And why is it impossible to apply to study data, like the thing you told us that we will have only in an advanced course? Haven't we already done something in
Well,
in
because
Python
everything.
quiz?
What do you mean?
We have like we worked with
About
the
time series.
already with the data frame, yes.
Okay, but you know what has been done in Python is for the stock prices has nothing to do with the econometric models that can be applied to time series. So econometric models for time series, they are built on some predictions of the future prices, some mathematical models that are related to this time series and all these things. So they are too advanced. If you start immediately talking about all this time series, you will be just lost in these things. So I hope you understand that I want to introduce all the concepts step by step. So from something simple to something advanced. So please trust me that time series is not the ideal choice to start studying econometrics. Yes, we can apply some calculations to the time series. We can apply to the stock prices, this random walk hypothesis testing, even though you don't know what is random walk yet. And some other things.
We have already talked about random walk.
Yes, but we haven't introduced the random walk properly and formally. What exactly is the model of random walk? What are the properties of this random walk and all the things? And well, I prefer not to mix all the things. So let me just show you. If we look at these books that I recommend you, these, and these, and if you open their contents, so you will see, for example, that, well, this Stock and Watson book, it has panel data introduced only in chapter 10, right? So it means that before this panel data, you need to know something, let's say, simpler. And time series, you see, it is introduced only in chapter 15. The same story here. Well, the time series is and panel data is put in the advanced topics part, right? So here we have time series and panel data. No, it's like the separate part also here about time series. When we talk about Hansen, even for PhD students, time series and panel data, those are in 443. Why? Because, well, when we talk about panel data, so the first problem, let me just maybe give you some preliminary explanation. If you collect the cross-sectional data, as we discussed, how can you collect the cross-sectional data for master degrees and salaries? You can simply collect a random sample, call to the people and ask them these questions. So something like a survey. And survey data is simple to collect. Now, the question is, how can you collect the random sample for the stock prices?
Collect it, like
No, it's not random sample.
collect
It's not a random sample. The problem with any time series that you have only one observation of the whole series of these prices. This is one observation. If you have, let's say, the sample of, I don't know, 5,000 days, formally, this is one possible outcome that you have from beginning to the end, from the start date to today. This is one observation. It's not possible. Conceptually, it's not possible to collect a random sample on the time series. And once we are not able to collect a random sample of time series, we need to conceptually understand what we should do with this. But before understanding what we should do with this, we need to understand how to work with random samples, right? We need to understand how the things work properly. And then we ask a question, okay, what if all our assumptions fail? Then we have a time series, and now we are in new troubles, like here, like I demonstrated you. If we cannot establish the causal relationship, let's solve some problems with this first, and then we will introduce new problems. So that's why for time series, it's not a good choice to start with. And it's kind of, sometimes time series are even not studies in econometrics. That was my choice to introduce some elements of time series in the second part of econometrics, because time series econometrics is completely different thing. It differs from the whole econometrics, and it is more advanced than the usual econometrics. So believe me, please. Okay. So that's why if we even if we use this data, I was showing you this data on stock prices because, well, first of all, it's amusing, right? So we see something fancy, so from something from the financial markets. And in those cases, well, more or less, we can apply those techniques because we do not want to establish the causal relationship of something and the stock price. Once we start asking the questions of causal relationship of a stock price and something else, we will get ourselves in big troubles. Don't oversimplify things. So that's my recommendation. That's the, if you want to be the proper data analysts, we need to keep all these restrictions in mind that, so here is the ideal way how I can answer the question. and here the problems that I see in my data, and here the best way how I can solve these problems and the best way how I can answer this question. It's not that simple. Well, yes, sometimes people tend to oversimplify things, but well, in most of the cases, if you want to properly answer the question, so you will see that, well, these things are not that simple.
Okay, thank you.
Anything else?
Only about statistic course.
Mm-hmm.
I text you on the site that I have like problems with the what was the number? Home assignment number 3, and
Number
I
3.
just the topic. Yes, I didn't like get the topic. And is there any way how can we? I don't know. Not just go through that again, but just didn't get the topic. What should I do?
Yeah, I got a message, as I said. So first of all, I will revise the results for the home assignment number 3 due to the incorrect grading of some exercises. Well, the best I can do is to provide you with some explanation of those tasks, what you were supposed to do. I can just prepare for you some extensive solution of this, so maybe with some video explanation if needed, and if you need, so you can just revise this. So basically, I'm a bit surprised that you were confused with this topic. Well, this topic is closely related to the next topic of confidence intervals, and if you are confused here, so probably it would be not also a good result here.
Confidence interval were understandable, but I just don't know how I didn't get the how do we come from the question to the how to solve it. Just
I understand what was the problem. Okay, as I said, so I will try to provide you with some explanation, written or video, so all these tasks and how these tasks were supposed to be solved. So you will get my support. Just please be patient, not everything at once.
Thank you.
And based on the results, I see that that's not only your problem. So I was a bit shocked when I saw the results for this home assignment. So hope for the next home assignments it will not appear anymore. So don't worry. So I think that's it. Then have a nice Friday evening and the weekend. Don't leave your home assignment for statistics till the very midnight of Sunday. I see that many people decide to make these home assignments at the very last seconds. So please be careful to your health, mental health and physical health as well. And don't leave it till the end. So you are already aware of the new rules, right? So that you don't see the results until the very end. And see you next Thursday.
Thank you for the class.
Bye-bye.